Okay guys, what we're going to look at now is adding algebraic fractions. So that just means that we have fractions with algebra in it. Okay, now that can mean we have something like a fraction with just with a letter. So it could be, for example, a over 2, or it could be 1 over 3x. Okay, these are algebraic fractions. We could also have an expression in the algebra, so in the fraction, sorry. So it could be something like a plus b over 3, or it could be 3x over 2x plus y. Okay, these are all algebraic fractions. Now, I want to just quickly look firstly at normal fractions. So when we're adding fractions together, you always know that we need to have the same denominator. Okay, so for example, if we had 1/5 plus 2/3. Okay, we know that in order for us to add these together, at the moment we can't do it, because if we had, say, 1/5 plus 2/5, we would get, well, you know, 1/5 plus 2/5 is 3/5. Okay, that 5's in a strange spot. All right, so if we have 1/5 plus 2/3, because the denominators are different, we can't do this. So we need to give them the same denominator. I'm just going to move this slightly so that I can show you what we're going to do. So we're going to do this with some numbers first, then we're going to try it with some algebra. All right, so 1/5 plus 2/3. To get a common denominator, we look for the lowest common denominator. Okay, so we want something that can be divided by both of those denominators. So what can be divided by both 5 and 3? Well, you can either just think about it that way. So something that can be divided by both 5 and 3, which we know is 15. Okay, and then we know that to get from 5 to 15, we times 3, etc. Okay, you can also just multiply by the opposite denominator. Okay, so this one, the denominator on the second fraction is 3. So we're going to multiply the first one times 3 on the bottom. And if you multiply by 3 on the bottom, you must also multiply by 3 on the top, because this is equal to 1. Okay, 3 over 3 is 1, and then we're not changing the fraction. Okay, we're not making it bigger, or we're not making it different. We're not changing the balance of it. We're just making it look bigger. All right, 2/3, the opposite denominator here is 5, so we're going to multiply by 5 over 5. Okay, so what we get is 1 times 3 is 3 over 5 times 3 is 15 plus 2 times 5 is 10 over 3 times 5 is 15. So what we get is 13 over 15, and we're done. Now with algebraic fractions, it works quite similarly. Okay, so for example, if I have 2b over 3a plus, let's say 5b over, or let's just say 5 over 2b squared. Okay, we've made this a little bit hard so you can see straight away. Now, those denominators are very different. There's nothing in common at all. Okay, so what that means is we're going to use the same method we used before, which is choose the opposite denominator and multiply by that. Okay, so for example, fraction 1, the first one on the left, the denominator is 3a. So we're going to look at the other one. We're going to multiply the top by 3a and the bottom by 3a. And remember, that is equal to 1. So we're multiplying by 1. On the left side, again, I'm just going to move this one over. I didn't leave myself enough space. On the left, we're going to multiply by the other denominator, which means we're going to do times 2b squared over 2b squared. Okay, and again, this is equal to 1. All right, what that gives us is 2b times 2b squared. Don't forget to multiply the 2's. So we're going to get 4b cubed over 3 times 2 is 6. A times b squared is ab squared. Now, some of you might be tempted to simplify here. Don't do it, because that just undoes what we already did. Okay, plus, let's look at the other one. 5 times 3a is 15a over 2b squared times 3a. So 2 times 3 is 6, and b squared times a is, remember, alphabetical order, ab squared. So now what we have is 4b cubed plus 15a over 6ab squared. And we're done. Okay, so you use the same strategy that we use for normal fractions for these ones. Okay, it doesn't really get much harder, just that sometimes, sorry, they will already have the lowest common denominator. So for example, or part of it will be, so maybe you get 2 over 5b plus 3a over, let's say, 4b. Okay, now you can see in this case, both of the fractions have a b, but one's a 5b and one's a 4b. So we don't need to multiply by the b because it's already there. You can if you want to, but at the end you'll need to simplify. In this case, we can just look at the numbers. So the left one, we're going to multiply by what's missing, which is 4. So it's going to be times 4 over 4. And the right one is going to be times 5 over 5. Okay? And remember, these are both 1. Okay, so we're just multiplying by 1, not changing anything. So we get 2 times 4, which is 8 over 5 4s are 20b, plus 3a times 5 is 15a over 20b. So we get 8 plus 15a over 20b. And that's our answer. So always remember to check at the end if you can simplify, because sometimes maybe all of these are even numbers, so you can divide them all by 2. But please don't ever go, well, you can see over here that we've got b, we've got an a at the top and an a at the bottom, so we can cancel these out. Okay, it's not correct, because remember, if there's a plus in there, you have to also be able to cancel it out of the first one. All right, you actually should factorize first if you're going to do that, which we can't do here. Okay, good luck.